Okay, so now that we have discussed energy levels, sublevels, and orbitals, now we're going to put all of this into practice in trying to figure out how electrons are arranged in a particular atom. The first way that we're going to do this is by using something known as orbital diagrams. So these orbital diagrams are going to help us explain how the electrons are arranged inside an atom. They're also going to tell us the order in which the electrons are going to be placed in a particular orbital. The orbital diagrams are based on using boxes to represent those orbitals, and we've seen examples of these before when we looked at the Pauli exclusion principle, for example. And your book uses colors to represent the different sublevels, but you may not see them color-coded on your quizzes or exams. All right, so let's take a look overall at what these different orbitals look like. So here we have them arranged in order of increasing energy. So the lowest energy is down here at the bottom, and it increases as we go upwards, right? So the 1s orbital, which is shown here, right? This is the lowest energy orbital. And then the highest one, energy orbital, would be the 7p. And they increase, the way in which we're going to fill the electrons in go according to this, this diagram. All right, you will notice here that each single box represents an orbital. So for the 1s, there's just one box because there's just one s. There's one s orbital. For the 2s, there's also just one box because there's only one s orbital. For the 2p, there are actually 3 boxes in that sublevel because, as we saw in the previous section, there are 3 p orbitals, right? 3 boxes means 3, in this case, p orbitals. All right, so we're going to be filling in our electrons into these orbitals, and when we put them in, we call it an orbital diagram for obvious reasons. When we start putting our electrons in, remember we're going to represent our electrons as arrows. Okay, usually put the first electron in as an arrow pointing up or spin up, and then if we have to fill that orbital, we pair it up with another electron pointing down. Spin down. Remember, your electrons have to be pointing in opposite directions so that they pair up properly. And the key thing now, in addition to that, in addition to pairing up the electrons, is the order in which we're going to fill the orbitals. All right, and the order in which we fill it is called, or we're going to fill it by increasing energy, beginning with the 1s and then until we've accounted for all of the electrons. That idea is known as the Aufbau principle. Okay, which literally translates to filling up from the lowest energy orbital till we've accounted for all of the electrons. All right, so a couple of things to also keep in mind. Remember, we talked about this in the last section. Your orbitals can only hold a maximum of 2 electrons, right? A single orbital, let's clarify that. A single orbital can hold a maximum of 2 electrons. So when you have multiple orbitals, well, then you just multiply how many orbitals you have times 2 to tell you how many total electrons they can accommodate. Another thing that we want to be aware of, and we'll see this when we look at a couple examples, is when you have a sublevel like the 2p sublevel. Okay, let me just redraw this over here. If I have 2 electrons to put into these 3 orbitals, you may be tempted to think, well, maybe I can put one here and then another one to pair up. Actually, you don't want to do that. You actually want to put one electron in each of the orbitals first until you have one in each, and then you start pairing up. All right, and that just has to do with the stability of the atom. It's way more stable to put one in each first and then start pairing them up if you have extra. All right, and that only happens when you run into a situation where you have sublevels that contain multiple orbitals, like the p, the d, and the f. So we're going to be putting our electrons in to arrange them according to the rules that we just talked about. And then when we put them in, we can represent those electrons by what are known as electron configurations, right? And this is a shortcut notation to indicate where the electrons are located. And we're going to write the configuration in the order in which we put the electrons in, from lowest energy to the next highest energy. The number of electrons in each of the sublevel is written as a superscript. All right, so if we take, for example, carbon, okay, carbon has 6 electrons, okay, and you can get that from the periodic table, right? Atomic number of 6 protons for an atom should have 6 electrons. So when we configure those electrons, we'll see that they conform to the following. So it'll be 1s with a superscript of 2, 2s with a superscript of 2, and then 2p with a superscript of 2. So the way that we read that is 1s2, 2s2, 2p2, right? Not 1s squared, 2s squared, 2p squared. So what do these numbers represent? Well, the ones, these big numbers, or the numbers at the front, these represent the energy levels, the principal energy levels, or the shells. The letters, so the S and the P's, those represent the sublevels. And then the superscripts, the 2, the 2, and the 2 over there, those are going to represent the number of electrons. All right, so if we add those together, 2 plus 2 plus 2, that gives us our 6 electrons. So how do we know that that's how we're going to arrange or configure our electrons? Well, we're going to use our electron orbital diagrams. All right, so if we start at the very beginning of the periodic table, we start with hydrogen, right, and we use our chart over here. Back up a little bit. We're always going to start with the 1s first, right? So we draw a box for the 1s. Hydrogen only has 1 electron because it has atomic number 1, and that electron can only go into the 1s. So we have 1 electron in the 1s, 1 electron in the 1s sublevel, so we just say 1s1. Helium has atomic number 2, which means it's got 2 electrons. So now that second electron coming in has to pair up pointing down. And we have our 2 here that tells us we have those 2 electrons in the 1s sublevel. So 1s2 would be electron configuration for helium. All right, so that's taking care of the first 2 elements in the periodic table, period 1, with hydrogen and helium. When we move to the second period, from lithium all the way over to neon, you'll see that lithium has atomic number 3, so it's going to have 3 electrons. So we're going to start with the 1s. So we're going to draw our boxes horizontally as opposed to vertically. And then we have our 2s. And then, if need to, we'll have our 2p with 3 boxes. Okay, we have 3 electrons to put in for lithium. So the first one goes in, second one pairs up. And then our third electron goes into the 2s. Right, we have no electrons remaining, so we can just disregard the other ones that are left. So we take that and we convert it, we end up with 1s2, and then we have 1 electron, and the 2s, that'll be 2s1. All right, and we can go through and fill in all of the electrons as we go across period 2. Let's do carbon, because carbon was one that we did previously as an example. Okay, so we said that carbon has atomic number 6, so it's got 6 electrons. So our orbitals that we start with the 1s, the 2s is next highest in energy, and our 2p has 3 of those orbitals. So we have 6 electrons. The first one goes in, second one pairs up, third one goes in, fourth one pairs up. And now we get to the p, and you'll notice the p sublevel has these 3 orbitals, right? And up to this point we've used 4 out of the 6 electrons. We have 2 of them remaining. So the first one goes in here, and the second one does not pair up. We actually put it in the neighboring orbital. All right, so we end up then with 1s2, 2s2, and then 2p2. Sometimes you'll see a shortcut used to represent your electron configurations, where we use what's known as the noble gas configuration or the abbreviated configuration. That's a shortcut that we use. And what we do is we put the electron configuration of the noble gas, which is in group 8, in square brackets. Right, so if we go back up here, we can see helium, which is a noble gas, has electron configuration 1s2. Okay, so then we can say this is the same thing as saying helium in square brackets 2s2, 2p2. All right, so the helium there corresponds to the 1s2. We can only use this shortcut for the noble gas abbreviation or the noble gas configuration. All right, let's take a look at a couple other examples. Let's see here. Let's do nitrogen. All right, this sample problem starting with nitrogen. So we're going to draw the orbital diagram for nitrogen. And when we look on the periodic table, so from the periodic table, nitrogen has atomic number equal to 7. Okay, so that means it should have 7 electrons. All right, and then we have our boxes drawn in. We have our 1s orbital here, have our 2s orbital, and then we have 3 of the 2p orbitals, right? These are right next to each other. They're connected because, remember, they have the same energy. But going from left to right, okay, generally we're going to be increasing energy, and we fill in the orbitals starting with the lowest energy first. So we have 7 electrons to account for. The first electron goes in to 1s, second electron pairs up, pointing opposite direction. Third electron goes in, fourth electron pairs up. Fifth electron goes into the 2p. Sixth electron doesn't pair up, fills in that second p orbital, and then the 7th electron fills that, or goes into that third p orbital as well. So we add them up. We have 1, 2, 3, 4, 5, 6, 7. So our electron configuration then, will be 1s2, then 2s2, and then 2p3. All right, so that's your electron configuration. And then what's in yellow here, this is your orbital diagram, right? Because it shows all of the orbitals as boxes and the electrons as arrows. So when you draw your boxes like we did here for the orbitals, right? How do you know the order in which to draw them? Well, you can go back and use, especially as you're getting used to it, you can use the table or the diagram here to show you the order in which we're going to be filling the orbitals, right? So we're going to start with the 1s, then the 2s, then the 2p's, the 3s, then the 3p's, the 4s, then the 3d's, then the 4p's, the 5s, and the 4d's, 5p, etc. That's the order in which you want to draw your orbital diagrams, and it's also the order in which your electron configuration is going to be.